Okay, so hello everyone. Thank you all for joining. Today the presentation will be about automating the boring stuff. And usually the boring stuff I'm referring at is, well, things that we run in our development workflow every day. And well, to my scene, it's something that we could automate or just let our robots do this stuff for us because not every time we want to run the same tools. Sometimes we have like a bunch of tools to be running. So I think that automating stuff like this is actually a good thing to have in any workflow development. So yeah, let's get started then. Well, for those who do not know me, uh, I will do like a quick introduction. So my name is Rodolfo Olivieri. I'm currently living in Brazil, and I work at Red Hat as a software engineer in the Converter tool. So, and you can find more things about me in my personal website. It doesn't have that much info there, but yeah, at least the basics and all of the important stuff you can see there. As well, other talks I will give in the future and blog posts as well. You all can see there. So yeah, what it is all about, this presentation. So the stock is the introduction to show that we can and we should automate some of the tools we use every day. And I have the intention here to show you guys like some of the tools that we run like day to day here in our workflow development, and how can we probably automate these with some CI systems. And well, probably most of the tools that we show here, some of you have already seen or used it before. But the intent is not actually teaching how those tools works, but rather show that you can use any CI system to automate them. So keep in mind that I will not go into much details about any of the tools, like the linters, formatters, and tests and stuff like that. I will not go into much details about that. My intent here is just showing two different CI systems that we can use to automate all of this stuff. So the presentation will be divided into two steps. The first one is going through all of these slides in the presentation, and the second part will be me showing a demo repository I have from all the things I will probably show here. So keep in mind we'll have this dynamic presentation. So what will be, actually, what is a CI system for the starts? So CI stands for continuous integration. And as the name suggests, it's a way for us to run our automatic workflow in a continuous way. So probably some of you have probably heard about other CI systems in the past, like Travis CI, Azure Pipelines, and AppVeyor. And well, we have like a bunch of other different CI systems. But actually, today we'll focus only in two that is not listed here, but we'll focus mainly on GitHub Actions and pre-commit.ci. The things we want to focus on this presentation is, well, since there is a bunch of things we could do in a CI system, I gathered a few categories that we should focus on, so we don't lose too much track it. And they are mainly linters, formatters, and testing. Okay, so basically in a CI system you can do almost anything you want. I have seen people building VMs in CI systems. I've seen people doing all sorts of crazy things there. But to keep the everything's simple here, we'll mainly focus on linters, formatters, and testings. Uh, okay, so what is a linter then? Well, a linter is a tool that analyzes the source code to detect bugs, programming errors, styles, security alerts, and much more. And we have a few examples of linters here. One of them is MyPy, which is, I guess, it's pretty common and lots of people have heard about it when searching around for linters. Another one is Bandit, which aims to do like security analysis on your code, static security analysis. And Flake8, which is like a wrapper for a bunch of different linters, all in one place. But we have like so many linters around, but those three, I think they are the most common linters you can find around, and probably examples on the internet as well. Uh, and then what is a formatter then? It's a tool that analyzes the source code, like the linter, but it can modify and apply consistent patterns to the source code. So instead of just analyzing your code statically and say, hey, you have a problem here or you have a bug here, a formatter will do that, but it also applies some patterns if it can apply. So some of examples we have for formatters, we have Black, which is pretty popular, AutoPep 8, and iSort. So, and of course, like linters, you have a bunch of others formatters, but those three, I guess, they are the most common search terms when we are trying to implement or use a formatting in our code. And lastly, but not least, we have test runners. And test runners are a way to run your invocation flow for your test, either being a unit test, integration, or any other type of test. I'm not going to list every single type of test here because I'm not a test expert, but the basic ones is just integration and unit tests. And for test runners, we have unit tests, which is from Python, Node2, and PyTest. And just recently, I discovered that Facebook open sourced one of their test runners, which I did not include here, but yeah, just wanted to commented this out because it was a surprise to me. And yeah, so how do we automate those tools? We're gonna see the CI systems that I mentioned previously, and mainly we will focus on GitHub Actions and pre-commit.ci. So um, the things that I will show here to you all, they can be kind of translated or parted out to other CI systems, but of course the workflows or the terminology can change between those systems. But for GitHub Actions and pre-commit.ci, it's pretty much it. Okay. So GitHub Actions is an integrated CI system that just works with every repository in GitHub, being it public or private, even if you have like your own instance hosted GitHub, so you can use the GitHub Actions there. And it just works with a minimal workflow configuration. So this is a very powerful CI system that facilitates our work when we want to do workflows that are either simple, complex, or anything in that range, actually. So you can vary like, oh, I just want to have a workflow that shows me if my code is passing my lint tests or my formats or my formatters. And it can go from that, or I want to have, for example, a workflow that builds my application and deploy that application to some registry. Or I want to do like integration with another repositories because I need information in other places. So the workflows can be very different. But basically, the complexity of the CI system is always the same. What changes the workflow you write to execute the jobs? And that's the nicest part of GitHub Actions. You don't need to take care of any of its internals. You just need to put your workflow together, and it's done, basically. So for everyone that doesn't want to first learn the CI and see what is going on and how this works, this happens, you can just pretty much write a workflow file and toss it into a repository, and probably it will work fine. Um, and there is a pretty comprehensive guide on how GitHub Actions works. It is pretty extensive, but if you guys can take a look at this later, if you find this interesting, GitHub puts a very nice documentation how their CI system work. So definitely check that out later because there is like some valuable information telling about the most simple to most complex things for GitHub Actions. And the second one I want to talk about is pre-commit.ci. So it's a CI system that works exclusively with the pre-commit tool. It can run your pre-commit configuration, auto-update the dependencies, and auto-fixes your code for you. In some cases, not every single case. But the pre-commit tool is a very versatile tool that enables us to run a bunch of different hooks before doing a commit. So, and those hooks are dependencies. That kind of depends on how the terminology you want to use, but often it's called hooks. So those hooks usually are the tools I showed before, like for example, Flake8 or Black or MyPy, and so on. So the big advantage we have with pre-commit is that we have just one tool to run every other single linter or formatter or stuff like that we want. So we don't need to remember like a bunch of different parameters or arguments to our tools, because pre-commit takes care of this for us in a nice way. So pre-commit.ci is basically a big wrapper around that. So instead of running pre-commit in your machine, you have this automate CI stuff that can run the same configuration you have, but in a cloud, and you don't have to take care of anything else. And if you want to learn a bit more about it, Precommit has a nice documentation that shows everything about the tool itself. So what are hooks? How can you create a hook? How do you use third-party hooks and things like that? And even has a search bar for you, so you can see like the official ones and uh, in all the other hooks that are provided for Precommit. And pre-committed CI itself also has documentation, but it's so simple that it almost doesn't have that much of information on their website, because it mainly you just click a button, connect your GitHub account with the pre-commit CI app, and it's done. Pretty much it. So the cool thing about pre-commit CI is actually the CI itself. It's checking, for example, if your pre-commit was run successfully, or if you have like an update schedule. So the installation and the configuration for pre-commit CI itself, it's not that much big of a deal. It's just like a button you click and everything just starts happening. So now I want to show you guys the second part of the presentation, which is the more practical stuff. So I have made this repository here, which is automate the boring stuff demo in GitHub. And this repository has a very minimal workflow configuration for GitHub, and as well some configurations for pre-commit that I'm going to show you. So keep in mind that this repository is just a getting started, so it's a really, really minimal thing. But it's basic. It's based on some of my personal projects that I like to do. So the structure of the repository is pretty much a structure that I'm very comfortable with working. So, but you can use it as a quick start, and it's pretty simple. So let me get here real quick. So this is the repository, okay? And you guys can see here we have like some folders and some files. I'm not gonna enter too much in detail here for what each of those files mean, but basically I want to point out the pre-commit config YAML here we have. So here we're gonna, oh, thanks Tocho, yeah, the repository. So here we have all of the configuration for pre-commit, and this configuration, like I said, is the same when we run it locally or in the CI, which is in the cloud for pre-commit. I'm going to show to you then. And we have this special folder called .github. And this folder is basically the central folder that all of the integrated systems in GitHub look for in our repository. So most of the bots that people use in GitHub are workflows or custom GitHub actions. They are located, they can be found in this directory. But yeah, first let me show you the pre-commit config file. Which is pretty simple. It's just a YAML with some repos configured. And here you can see, like, for example, we have this repo thing where we place a GitHub URL here. So this one, this pre-commit hooks is the official pre-commit hooks. There are the official hooks for pre-commit. And we have this other mapping here called hooks, where we define all of the hooks we want to call that lives in this repository. It's kind of when pre-commit runs, it will look up into this repository, clone it to your machine, and if it finds any of these IDs or any of these hooks defined in your config, it will run automatically for you. So for example, in the official pre-commit hooks, we have trailing white space, which will remove any white space in lines or end of lines it finds out. and a file fixer, which is it adds a white space line in the end of your file, but without the trailing white space here. It's just a new line at the end. And we have like a bunch of other as well. So check text strings first, check YAML. It validates if the YAML is syntax is okay. It checks for the bugs statements in Python code. It checks if the tests you have is with a specific convention like main underline test.py, for example. And here we can define basically all the things that we want. So here we have the pre-commit hooks, which is the official one. We have a hook for black, the formatter. So it will run black every time we run pre-commit for us. Flakate, and we have like some others that I just put here to show. Like for example, PyUpgrade, which will try to convert your code from older Python versions to newer Python versions whenever it can. So we have reorder Python parts, edit trailing comma. We have a bunch of different hooks. And basically, who made those hooks is the community or anyone actually. So you could make your own custom hook and use anywhere else. I have a repository which is a pre-commit hook, but it's not for Python, it's for Rust, and I can show it later if you guys want. But it's pretty simple, it's pretty easy to do, and the configuration file for pre-commit is also pretty simple. So basically, it consists of a repository, a version using the tag systems from Git, and the hook ID you want to use, and if your hook or your program you're trying to run with pre-commit has any args, you can pass it here, or like any custom dependencies or any custom thing that you want to run. With that hook, you can just pass. It's a pretty simple configuration file. Uh, and that's what pre-commit.ci reads when it's trying to run our code. Um, okay, so yeah, now moving on to the .github folder. This is I guess, the most interesting part of the presentation. The pre-commit itself is pretty simple, so I don't have much to talk about it. But inside of the .github folder, we can have any structure we like and any files we like. GitHub is not, it does not enforce that much of a structure inside this. The only thing that I think that GitHub Actions look for when it's running any of its integrations is this folder here, the workflows folder. And any other thing that you can place here will either be for pull requests or issues template. That's one of the things you can do with GitHub repositories. So you can define a pretty nice template for your pull requests and issues. And mostly bot configuration. For example, the Panda bot here has all of the configurations for the Panda bot. And in the workflows, this is a special folder that GitHub Actions use, because every single file you have inside this folder right here, GitHub interprets this as being one workflow for your repository. So all of the configuration using YAML. I think you can't use any other format, only YAML for the GitHub Actions. And right here I have just this minimal workflow called coverage. And I'm gonna do a quick introduction of this format. It kind of seems like strange at first sight, but trust me, this is rather simple. And like with a couple of minutes going through the documentation or looking at other examples, you can find your way inside of every workflow, basically. So the first thing we have here in this workflow is this name key, which will be the name for the workflow itself. In my case, it's coverage, but it could be anything else. It's just a string that you can identify your workflow. But the main important part here is this section here, which is this on key. And this part, it defines the events that will trigger your workflow. So GitHub has a lot of different events that can trigger a workflow. This one is pretty simple. Basically, I am saying that on every push request to the branch's main, or any pull request, and independently the name of the branch or anything like that. So every pull request and every push to the main branch, I want to run this workflow. Okay. But actually, GitHub has things like, for example, you can run your workflow based on a tag, which has this special regex that searches for something. So you can either run that, or you can trigger it manually. You can trigger your workflow based on another workflow. You can trigger a workflow based on another repository that has a different workflow. So it's a pretty customizable thing. And basically every single workflow I have seen so far that it is not like something out of this world uses the same technique. So you have like a push event and a pull request event because they are the most common, and um, almost all of the workflows use that. Um, but here I have the documentation that shows every single event that can trigger the workflows. And if you guys want to check this out later, you can. And yeah, so the next thing we have in this workflow is the jobs keyword here. And this is used to define every single thing that has to be executed in our workflow. Think of jobs like containers. So for example, the test job I have right here is like my container, which will define each step and each thing that will run inside that job. But I could have here like more than one or like thousands of jobs that could run inside this workflow. But one common practice that people usually do is not putting a lot of jobs inside your workflow. They tend to create a new file if the job is kind of different from the previous one. And let's say you have a workflow for testing your project and another workflow for deploying to PyPy, for example. So this should be like two separate files with their own jobs and steps and things like that. So, but nothing stops you to put like hundreds of jobs here, and GitHub will execute this without a problem. Moving on then, we have another, again, we have the name keyword, uh, which will define the name of the job. This keyword is not necessary, only if you want to do a custom name for your job. Otherwise, if you don't have this key here, GitHub Actions, you assume that the name you put in your job, or actually the key that you put as a name for your job, will be the name that it will be used. So this is more like it's a way of to overwrite the job name and make it look more pretty. And one of the nicest things we have about GitHub Actions is the ability to run the same workflow in different environments. So if you see this keyword runs on here, uh, most of the times you will see that it's pointing out to Ubuntu latest, but GitHub Actions actually provides us the ability to run in Ubuntu, Windows, and Mac OS. And not only the latest version for each one of those systems, but I think they maintain two versions back for every single one option. So you can test out your code, or you can run out your workflows against pretty much the three major systems here, which is pretty cool, this feature. And I know that in other CI systems, you don't have something similar to that. You can do this, but there are some CI systems that only runs on Linux servers or Windows servers. So you kind of basically you don't have this flexibility. But GitHub Actions actually allows us to do this, which is pretty cool. And then the next step of a workflow is actually the steps. And the steps, you basically say what you want to be running inside your job. So for example, I have a few steps here, and they are pretty much common. The first one is called actions/checkout. This will basically help clone our repository and check out to the specific branch or commit, or any other form that you want to indicate to Git that you want to check out to something. Usually this checkouts to the branch from the PR or the commit that is running, but you have a way to pass different options to the checkouts action to modify this stuff. Uh, the second one I am using here is the cache action. And this cache action here, it will get everything that lives inside a specific folder. In this case, the specific folder is the pipe folder, and we cache into the some GitHub storage that I don't think we have control over it. Uh, but basically, it will install all your dependencies, and once your workflow finishes, or rather your job finishes, it will take everything that lives inside that repository and save in GitHub storage. So the next time your workflow executes or this job is getting called again, um, uh, the GitHub actions can look through this key or an automatic key. This is not necessary to define, but it look out from this key and say, hey, I found a key, so we have a cache for this specific workflow, this specific branch, or this specific scenario. So download everything you have, and so the user don't have to run pipe install again, or install any of the dependencies on the machine. And lastly, here we have an action to set up Python. So when we run the workflow and the jobs in any of the machines like Ubuntu, Windows, or macOS, we don't have anything set up, basically. It's just a bare box without nothing, and you have to install everything that you use. And Python is no exception. So GitHub has made this custom action to us, so it's called setup Python. When you can say the Python version we want to be installed, and the architecture as well. So we can specify different architectures for the Python to be installed on the machine, which is pretty convenient, and you don't have to do manually like apt get install Python or any other package manager for the machine you are running. So it's pretty convenient. And the last two here is a custom action, let's say, or a custom step, if you prefer. And this custom step is installing Tux. And then the last one is actually calling Tux with one of my specific tests for Python. And Tux is also a test runner that we have. It's more like a development setup that you can run tests and all sorts of stuff. And in all of my projects, I use Tux because it's really easy to set up, and you can have like different versions of Python to be running and control them individually. So basically, this is the layout of a workflow file, and it is mainly composed of actions, like third-party actions or official actions from GitHub. And you can see that this is the official action because of the actions prefix. So every time that you see actions slash something, and doesn't matter what the other thing is, you can know that this here indicates that you are using an official GitHub action. But if you are not 100% sure if the action you are using is from GitHub, or it's like a official action or something like that, GitHub has put a marketplace. And in this marketplace, you can check out all of the GitHub actions that you can use in your workflow file. And also you can check out the third parties actions from everyone who wants to make one. So probably if you do a custom action to use in the GitHub actions, your action will be listed in the marketplace. Although I don't know if this is automatically listed there or you have to register, but I believe it is automatically, because GitHub detects when a repository is set up to be a custom action. But yeah, it's pretty basic, pretty simple. Basically, you define everything you want in forms of steps. So first step should do this, and second step should do that, and so on. And you can actually have this being being run on every single time your workflow. So you have these identical workflows, no matter the PR or no matter the commit you are doing, you will always have the same commands being run uh, to check against anything that you want, basically. And the last stuff I want to show here is basically the pre-commit side of the story. And I have prepared this like 2 days ago because today GitHub is a bit of unstable, so I wouldn't be able to demonstrate that for you all. But basically, this first PR here we have, it's pre-commit itself updating our dependencies or hooks. And the second one is more interesting because I had a PR, and in that PR, my code was not formatted very well. I had like line breaks, and the code was not formatted properly. So pre-commit CI detected that for me and actually fixed the code. So this is the two main cases I want to show. And of course, in both of the PRs, I have my custom coverage workflow that I wrote that I just showed it to you guys. So we're gonna show that as well, like the run that was made. Uh, so the first one here, the pre-commit auto update, you guys can see that this was made by a bot, which is the pre-commit CI bot. And it updated to us from one version to another for pre-commit hooks, by upgrade, the other imports, and so on. So I didn't even have to touch my configuration file. It auto-updated for me. So it's a pretty nice feature we have. And here you guys can see that it just updated only the specific versions that was changed, that pre-commit CI found out was different. You can achieve the same effect if you run this locally, like pre-commit has this command called auto-update. You can achieve the same effect, but then you have to run it every single time and open a PR every single time that something changed. With this, it's basically automatically. And the second PR I wanted to show is this one. So you guys can see here in the commits history, the first commit updating the main.py file, and it actually failed, and it failed in the pre-commit itself. But the second one passes because pre-commit was able to auto-fix my commit. Um, so showing to you the pre-commit CI page, which is this one. Let me see if it will. Okay. So here we have my repository, the automated boring stuff demo, and the number of the PR, which was the PR3 I opened it. And here you guys can see the output of the pre-commit. Everyone who have run pre-commit before locally, you see that this is the same output we get when we run it locally. The difference is just that it's showing in a website for us. And here you guys can see that black was, well, actually fixing the files in black failed. These two rooks failed for me. And while black was reformatting my file because it was not properly done, pre-commit actually pushed the fix to me. So basically what happened here was when I opened my PR, pre-commit CI got that PR information, added to a queue, then it ran a mergeable check to see if the PR can be mergeable, cloned my repository, validated the CI config, pulled the image, that is the runner image. This is something that pre-commit also provides to us. We don't have to manually set this or anything like that. Build all of the pre-commit dependencies, which is the hooks that I defined in my configuration file. So flake8, upgrade, edit trailing command, and so on. And lastly, it run for me the pre-commit too. And since this failed and it pushes automatically to my branch, we can see here that the next time it runs, it passes now because it actually changed everything to me. So everything is great. So everything passes normally because pre-commit took care of that failed output in one of my rooks and automatically pushed the fix So pretty nice, pretty cool feature they have. And actually, pre-commit.ci is basically um, the pre-commit.ci itself is basically those two features, the auto update one and the auto push fixes. So those are the main reasons that we should use the pre-commit.ci and not like do our custom workflow for pre-commit, because uh, uh, but we should do something custom if pre-commit.ci do all of this stuff manually to us, actually automatically to us, and without much hassle. Like I said in the beginning, you just have to click a button and select your repository, and everything's done for your next PR and next commit and so on. Uh, Even though I don't have any file changes, but the PR is still open on GitHub, which is kind of strange. But basically now the file that was fixed is identical to my file. So uh, I think I can look at the commit here. Yeah, here. So I added a bunch of lines at the end and did a line break here in the hello world. And this was the thing that pre-commit fixed for me. So yeah, pretty cool stuff. And yeah, I believe this is the what I wanted to show from this repository. Let me go back to the presentation here. Okay, so and one last thing I wanted to basically just tell you guys is that if any of you have ever used a cookie cutter before, which is a Python tool to generate to bootstrap projects, and not only Python projects, you can bootstrap any sort of projects actually. If anyone has used this before, I made a custom cookie cutter project, which defines basically what I just showed to you into the automated bar stuff demo repository. It defines the same structure, but with a custom, with more workflows there. So I have one workflow for the coverage, one workflow to deploy the package to PyPy. I have, like more workflows than I just showed about the coverage. So if anyone is interested to learn more about GitHub Actions and all the workflow stuff, this repository contain easier and more complex workflows defined. So go check out if you find this useful. And yeah, and here by the end, I just wanted to show some of the reference that I used to make all of this happen. So if anyone is interested as well, I will post the link for this talk later, and you can see all of these, the reference that I used. And yeah, I believe this is it then. So yeah, thank you so much for joining the talk. I hope I could teach something all of this, and sorry if it was not meaningful or I didn't do a good job explaining. But has anyone have any questions about this, about all of this stuff?
What do you think are the like the two top um, linting tools that you would recommend everyone set up a workflow for?
Okay, so I think that I would recommend MyPy for if it is a Python 3 project and beyond. I would definitely recommend MyPy because I really like types in my code. So I think it's pretty useful when someone else is trying to read their code and uh, you know uh, they might see a variable but don't know what is actually that variable. And MyPy is it's kind of a pain in that sense. So if you have something that is not typed out or it's not clear enough, it will complain. So you have to go and update the types for that variable or function or anything like that, actually. So I would definitely recommend MyPy and Flickate. I believe those two are the most common ones that I have seen in most of the projects I worked so far. So yeah, MyPy can be a bit of a pain to configure in the first time, but if you use my cookie cutter template, it's already configured, so you don't have to go through that. So it's basically just running and fixing the outputs. And also Bandit. If you care too much about security, Bandit is also good because the focus is only security and not anything else. So, for example, Flake8 will not every time look for security things, but Bandit is more towards that. So, yeah, probably will be this my advice. Okay, so anyone has any other question or comments too? Don't mind. Uh, yeah, so I guess no. I guess I don't have any other questions. Uh, so just let me send here in the chat the link for this presentation. Yeah, is this one. So like I said before, in my personal website, you can go and find all of this stuff that I have. So my talks and my blog posts. So yeah, you can go out and just check if you have any doubts or just wanted to see any of the links I presented here. They're all linked into this presentation. So yeah, thank you so much everyone for joining, and yep, guess it's it then.
Thanks, Adolfo. That was a great talk. I I haven't used GitHub Actions for anything up till now, so it was a great introduction to what we can do with them.
Yeah. It's pretty good. It's pretty simple, pretty good. But with every other CI system, you just have to pass the trial and error process because I don't think there is any other way that you can test it without just writing something, pushing, and see it fails, and then go back and fix, and just go through this process until you get this done. So yeah.
Do you usually do that trial and error with like a production repo that you have, or do you kind of set up a test repo and test things out, and then once you get it working, you then push it to all your production repos?
Oh yeah, so that is actually a good question. Usually I tested it with some other repo to not pollute the Git history or like open 100 PRs in that main repo. But if you are working with forks, so you have the main repo, like the production repo, and then you have a fork of it that you work, then most of the times you can just test against your fork, and when everything is set up and ready, you can just open a PR for the main one. This works fine because in GitHub Actions you can, so for example, using convert_rel as example right now, if we have a specific workflow for like testing our coverage. This will be running convert_rel every single time we open a PR and push and so on. But if I have a fork of convert_rel and do the same process, open a PR to my own fork or do a push to my own fork, following the rules for the event trigger in that workflow, I can test out the workflow in my own environment. Probably if the workflow has some secret variable or some like configuration that you are not supposed to have because it's something internal to the company or the project you are working, then this specific part you won't be able to test. But basically, almost everything else you can test in your fork or your custom repo. But basically, if I work with forks, a fork of a project, I would test in my fork. If I have a repo of mine, then I would just create a mirror repo just to test this out. And once everything is set up, then I pass to the original one. Yeah, but there is not much secret. It's try and error. So uh, if you know very well the syntax for the workflows, then you are probably not getting too many errors out of your testing. But if it's your first time and you are still learning, then probably it's more trial and error until you get this right. Well, okay, then I'm gonna stop the recording now. If anyone has anything else. So